Hello, in this video we will examine simulating discrete time models with two variables. So in the previous videos we simulated discrete time models with one variable, and now we will look at models with two or more variables. So as an example, consider a model of cows and grass. Let x sub t be the number of cows at time t, and let y sub t equal the number of square meters of grass at time t. So here's our model. Notice that it looks a little bit complicated, and the reason it looks a little complicated is that these equations are coupled. In our first equation, we have x sub t equals 0.5 times x sub t minus 1 plus y sub t minus 1. The second equation says y sub t equals negative 0.5 times x sub t minus 1 plus y sub t minus 1, and then we're given some initial conditions. So the number of cows at time 1 is 1 cow, and the number of square meters of grass at time 1 is also 1. I'd like to look at these equations in more detail and see, how do they make sense in the context of the cows and the grass. Okay, so first of all, let's look at this equation right here, which is for cows. Okay, so let's look at our cows equation. So what this is saying, x sub t, that represents the number of cows at time t. Okay, or if you want to just shorthand it, it'd say x and y. This is really the number of current x's. Okay. So it's our current state of the system for x. And then on the right hand side, we know that x sub t equals 0.5 times x sub t minus 1 plus y sub t minus 1. Let's see, what does this mean? This term right here, 0.5 times x sub t minus 1, this means that we have half as many cows as we did in the last time step. So only half of existing cows from the past survive, and that's kind of a sad model, but we're just making up models here, and we could always change that to be more realistic. And then this plus y sub t minus 1, what that means is that we're going to make new cows. We're adding new cows into the system. We're adding new cows. In other words, that's reproduction, right? We're reproducing here. So we're going to add new cows into the system, and we're going to add one new cow for each square meter of grass, right? For each y sub t minus 1, you're going to add in a new cow. So what's this saying? It's saying the number of cows at time t, so our current x, it's a function of the past, and it's a function of half of the x's from the last time step plus all of the y sub t's in the past time step, and that's kind of like food or reproduction, some sort of measure there. Now let's take a look at our other equation. This is y sub t, and this represents the number of square meters of grass that we have. So this is the food for the cows. Okay, so let's take a look at that equation. So y sub t, so this is the number of square meters of grass, and you could just say, simply put, that is basically the current state of y. It's simply negative 0.5 times x sub t minus 1 plus y sub t minus 1. What does this mean? Well, the cows have been eating the grass, so we're going to have less grass in the system. So we start with all of the grass from the previous time step, and then we're going to subtract, right? This minus here tells us to subtract or reduce this grazing effort of the cows. So each cow is going to eat half a square meter of grass. Okay, so the grass is helpful to the cows. It helps them reproduce, and we saw that up here in the cow equation. But the poor grass is getting munched down by the cows. The cows are going to eat it, so that gets reduced a little bit by the function of the number of cows you have. And then these x sub 1 equals 1 and y sub 1 equals 1, this part just means our initial conditions. Okay, so we're ready to get going with the model and simulating this in MATLAB. So in MATLAB, here's our game plan, pseudocode, or kind of outline of what you're going to code up. The first step you need to do here is initialize the variables. Now, one thing we have to consider is, how long are we going to run the simulation? So let's let time steps equal 30. We'll run it for 30 time steps. We could always change that number, but that's a good place to start. We also need to set up an array for X and an array for Y to keep track of the number of cows and to keep track of how much grass we have. So we'll say X is equal to zeros, and we'll make that a matrix or an array which has one row, and the number of columns will be however many time steps we're using. And again, I'm putting in the variable time steps there so that this code is more flexible each time I run it. If I wanted to just change the 100 or 1000, I don't have to rewrite all my code. It's just one number that I would need to change right here. And then Y equals zeros, 1 up to time steps. So we've got one row and some number of columns. And then we will set our initial condition, so we know that when time is 1, we've got 1 cow. Maybe suppress that output. When time is 1, we have 1 square meter of grass. And then we can run the simulation. So we'll have some sort of for loop here. Now, we've already decided what's going to be going on for time equals 1, so we just need to figure out time equals 2 and beyond. So for t equals 2 up to the number of time steps, we'll code in our model. So x sub t will equal 0.5 times x of t minus 1 plus y of t minus 1. And for our grass simulation, we've got y of t equals negative 0.5 times x sub t minus 1 plus y of t minus 1. And that will do it. We'll end our for loop. And then lastly, we'll visualize the data. And we want to do 2 different visualizations here. Let's visualize the time series. And also the phase space. Okay, so for the time series, we want to do some plotting here. We want to plot maybe 1 up to time steps and take a look at our x variable, and maybe we could make this red. And then we also want to do another plot, 1 up to time steps on the horizontal axis. And we'll plot the number of square meters of grass we have. Maybe we could put that in green for grass or something, or blue, doesn't matter. But we want to put different colors there so we can see which curve is the cow curve and which curve is the grass curve. And then we'll do a phase space plot, and that's going to be a plot, and that's going to be x versus y. Okay, so we'll get to all that in the next video. We will code this up in MATLAB.